Let's record this. So, solving systems by elimination. This is our goal to finish our different methods of solving. So, elimination is great when both are in standard form. And standard form would be ax plus by equals c. And, it will be very obvious when it's set up for elimination. Make sure you have opposites in your first step. If no variables are opposites, we will need to make opposites by multiplying one or both equations. We'll see examples starting with us already having opposites, and then we'll see an example where we have to multiply one of them, and an example where we have to multiply both. Step 2 will then say, add the equations together. So if I have opposites, if I have a 2x and a negative 2x, what happens to that when I add those together? 2x plus negative 2x. What would happen there? If I had 2x plus negative 2x, what happens? When I add them, yeah, they're zero, they cancel out. That's the whole point in step 2. You'll get them to cancel out, and then you'll solve whatever's left. Now, step 3 here is actually the same step 3 from substitution. Plug in that solution to either equation and solve for the other variable. And then step 4, write it as an XY point. So elimination's actually not too bad once you get the hang of it. We're going to start with examples that are just opposites, so it's going to make life really easy. Because we could just go straight to adding. There are ones where we'll have to make opposites. Those are a little tougher, but once you have the opposites, again, if you just add them together, they're going to work just how we need them to. So make sure you got this down. Go give you a second to get that down. I'll just kind of hang out up here, because I do have the Zoom going and people are there. So in case you have questions, I'm available at the chat. And make sure you're getting this down. I see a lot of people writing now. So I know for the recording, it's just a little bit of a pause, but that's okay. Just remember, honestly, if you're rewatching the recording, you just might want to fast forward through this bit till you see me get to example one. So see if you're writing, that's absolutely fine. Just give me a second to get there before we go to example one. Again, just quick review of these steps to list you are finishing up. Make sure you have opposites. Again, we're going to start off with examples that do have opposites, so life is a little easier there. Once we know we have, or if we don't have opposites, we're going to need to make them by either multiplying one or sometimes both of the equations. Once we have the opposites, though, all we're going to do is add them together to get the variables that are opposites to cancel. And then we'll solve for the remaining variable. Step 3, we're going to go back to what we were doing with substitution. We're going to take that answer we got, plug it in, and solve for the other variable. And then step 4, write it as an XY term. So this way. Okay, here with this. This is going to be our common setup for elimination method. Notice I have x over x, y over y, equals over equals, and number over number. That's going to be our big key setup here. So I have x plus y equals 8, and negative x plus 2y equals 7. Do I have opposites here? Do I have opposites happening anywhere in here?
Yeah.
Yeah. X and negative x, those are our opposites. Now, you don't have to circle and say what your opposites are every time. I'm identifying them for you right now. So let's take a look. It says to combine and solve. So I have x plus y equals 8 and negative x plus 2y equals 7. So let's combine those. What happens when I add x plus a negative x? They cancel out. There are opposites. What's 1y plus 2y give me? 3y. What's 8 plus 7 give me? 15. Now what would I do to finish this up? Divide by 3. And y is equal to 5. That's the elimination part. Any questions on that, like, new step? All I did was add them together because I had opposites. One of my variables eliminates, hence the name elimination method. Now, do you guys want to plug that into the top equation or bottom equation? It does not matter which you choose. I like the top slightly better for ease purposes, and that's what we're going to go with. And I'm going to explain why I like you saying top instead of bottom here. So the top, if you notice, it's just x and y. My numbers are smaller than on the bottom one, right? Also, the bottom has that negative in there, right? If I can avoid working with a negative, it makes my life easier. So let's take this and plug it in here. So that will give me x plus, instead of writing y, I'm going to plug in 5 is equal to 8. Oh, this is easy to solve. What would we do to finish this? Yeah, let's just subtract 5 from both sides. X equals 3. So that we just write our point, 3, 5. Now, again, we'll go back to graphing because Desmos is nice and will allow us to graph it like this. And we'll check that, yes, indeed, the 3, 5 is where these two lines cross. So we were able to make that prediction without actually graphing it and seeing where they physically cross. We'll look at that in 1 second. So we'll just see a few people getting down the end of this example. So I want you to get that before we use Desmos to check. So I can do it this way. I don't need to go full screen on it. So I'm in Desmos. There's your little copy. It's coming back in a second. Graphic calculator. So if I do x plus y equals 8, and then x minus, you can go to the bathroom if you need to. So if I type it in like that, oh, I put it in wrong equations. It should be negative x, and that's plus 2y. There we go. I do get 3, 5 when I graph both of these and see where they cross. So indeed, we were able to check that out there. Any questions on the first example? Okay, let's look at the second example. Oh, this one's interesting. Here I have 4x minus 5y equals 7 I also have negative 4x plus 5y equals 7. Do I have opposites here?
Yeah.
Yeah. Oh, the x's are opposites and the y's in this case. So let's just get to adding and see what happens here. So it starts out, 4x minus 5y equals 7, and then negative 4x plus 5y also equals 7. What happens when I add the x's? They cancel. What happens when I add the y's? Cancel out too. Miswrote this. Sorry about that. That should be 7 right there. And 7 plus 7 gives me. Now, if everything canceled out on the left side, what should I put over here? 0, because nothing's left. Is 0 equal to 14? So that is no solution. Very good. 0 is not equal to 14. So this has no solution. So when I added everything together, if I got 0 equals 0, that would be infinitely many solutions. But since I got 0 is equal to a number like 14, that is no solution. If we were to graph these, we would see 2 parallel lines. That's example 2. Those are examples when we already have opposites. The next 2, we're going to have to make our opposites. Once we make our opposites, life's just as easy as these last 2 were. So let's take a look at example number 3. I have x plus y equals -7, and I have 3x plus y equals -9. Do I have opposites right now? No. However, I can make opposites. Now here, they already started their creating opposite steps. So we're kind of forced into which one we're going to make opposites. But you can choose whether you want to make your x's opposites or your y's. In this case, I chose our y's. If I have a plus y and a plus y, what would I have to make one of them to become opposites? If I could get one to be a negative y, I get opposites. So they're creating opposites by multiplying by -1. So all they're doing is going to distribute a -1 to everything in here. And that will give me -x minus y equals 2 negatives. -1 times -7 is a +7. And then the other equation remains untouched. 3x plus y equals -9. Now I have opposites, right? So let's add them together. What's -x plus 3x give me? 2x. What happens to the y's? And what happens here? 7 plus -9. -2. Good, good. Finish it up. Yep, let's divide by 2. X equals -1. Now, again, it really doesn't matter which one do you want to plug this into, top equation or bottom equation. I'm liking the top slightly better as well again, just because having the 3x there, the number's just slightly bigger on the bottom. It's really not going to make a difference. We decided to go with the top. Let's go with it. So I'm going to plug that in here for x. So that's going to give me -1 plus y is equal to -7. What do I need to do to get rid of the -1? Yep. That gives me y equals -6. So my solution will be -1, comma, -6. And we'll look at that graph together in just a moment. So we'll see these two lines cross at the point -1, comma, -6. So as you see, once you have opposites, this elimination method just kind of is like, oh, add them up and go from there. It's not too bad. When you have to make opposites, life can get a little trickier. I'm not going to lie to you there. But it's not too bad once we get moving on. Okay, let's take a look at this one. So that's x plus y equals -7. That was the first line. The second line, 3x plus y equals -9. And if I click on where they cross again, we get -1, -6. That's the same answer I got here. Now we're going to get about as complicated as we can get here. I'm going to create opposites the hardest way here. There's one way that's slightly easier, but I want to show you the slightly harder way just so we can do it. So here I have 4a plus 7b equals 11, 2a plus 3b equals 5. Are any of these opposites right now?
No.
No. So we're going to have to pick a letter to be opposites. Which letter do you guys think would be easy to make opposites right now? A or B? A is going to be the easier one. Because if I do 2 times 2, that gives me 4, right? So if I made it a -2, I'd get my opposites, right? Now, I'm actually going to go the harder route. You guys were right. A is going to be easier. I'm going to try and make my B's opposite here. But is there anything I can multiply 3 by to get to 7? Well, whole number wise. Can I do like 3 times something to get 7?
No.
Not with whole numbers. So that puts me in a predicament because I could do 2 times 2 to get 4, right? So since these don't, I can't just multiply to get there, here's what I'm going to do. See how 3 is in front of the B on the bottom? I want to multiply the top by 3. See how 7's in front here? I'm going to multiply by 7 on the bottom. So I'm kind of doing what's on the bottom, multiply the top by, what's on the top, multiply the bottom by. Now, I don't have opposite signs, so I have to make that one of them negative. So I'm going to make the 7 negative. So let's see here, 3 times 4, that's 12a. 3 times 7 will be plus 21b. And then 3 times 11, 33. Same thing on the bottom row. -7 times 2, -14a. -7 times 3, -21b. Now I got those opposites, and -7 times 5. Oh, times 5. 35. It's all good. We're all waking up. I get it. Let's add them together now. 12a plus a -14a. What does that give me? -2a, good. What happens with my b's? They cancel. That was the whole point there. And 33 minus 35, -2. Well, what I do to finish it up? Divide by -2. A is equal to 1. Let me write that meter. Sorry about that. A equals 1. Now again, which one might you want to plug this one into? Top or bottom? Top's not bad. I'm actually going to go with the bottom on this just because I have smaller numbers. It really doesn't matter. Honestly, looking at both of these, they're all positive. The numbers aren't too big on the top, but I know if I got smaller numbers like in the bottom, there's even less chance for me to make a mistake. So it really doesn't matter. This is going to go in for A here. So I could do 2 times 1 plus 3 times B is equal to 5. 2 times 1 is 2. So 2 plus 3B equals 5. Subtract 2. And we get 3B is equal to 3. What would I do to finish it up? And we have B is equal to 1. So usually we write our points as XY points, always just go in alphabetical order, A, comma, B. So that's 1, comma, 1. So that's it. That's the ideas with elimination. We still have a half hour left in class just about. So please use that time to get started on or whatchamacallit, the classwork for today. Hopefully you can get it done close to the first 12 done before the end of class. If not, try and finish that up for homework.